Here's a clever counting method called the principle of inclusion and exclusion. It helps us count correctly when some numbers belong to more than one group. Instead of guessing or accidentally counting the same number twice, we'll learn a simple strategy that mathematicians use to solve these problems with confidence. How many numbers less than 501 are divisible by 3, 5, and 7?
But like, how would you know how many numbers are divisible by 3?
You have to divide 500 by 3.
Yeah, that's it, right? Like, I'll just give an example. Like, obviously, if you're looking at all the numbers that are less than 10, and you want to find those that are divisible by 3, right? Obviously, those are going to be 3, 6, and 9. So there's supposed to be 3 numbers, which you could just easily get using 10 divided by 3. 10 divided by 3 equals 3 remainder 3. I mean, that's quite simple, but do you know about the floor function? Have you guys heard of that or seen it before? Okay, it basically looks like this. Right, so 10 divided by 3, right, gives you 3 remainder 3. Or if you want like a fraction, like 3 and 1/3. But this one, if you have the floor function, you just basically want the whole number. So it just becomes 3. You don't want the decimal or the fraction. So just a few examples, right, would be 100 divided by 9, floor function. Okay, what would this one be? If I don't want the fraction or the decimal.
11.
Yeah, 11. Because it would have been 11 and 1/9s. But I don't want this anymore. I just want the 11. Does anyone have any questions for this part? Nope. I think it's quite straightforward, yeah. Right, so if I want to find the number of numbers that are divisible by 3, what do? It's just 500 divided by 3. I don't divide 501 because I want the numbers that are less than 501. So that's 1 to 500, yeah. So I don't divide 501. Yep, so this one is 166. So there are 166 numbers that are divisible by 3, right? So if we do the same for 5 and 7, there are 100 numbers that are divisible by 5 and 71 numbers that are divisible by 7. So for example, like the numbers that are divisible by 3, those would include 3, 6, 9, 12, 15, and so on. Divisible by 5 or 5, 10, 15, 20, and so on. Divisible by 7, 7, 14, 21, so on. Yeah, so I mean, if you look at these numbers, these are the numbers that are either divisible by 3, 5, or 7. Like we can't have a 2 because it's not divisible by 3, 5, or 7. Yeah, so do we just add everything here? Do you think that's going to be the answer? What's 166 plus 100 plus 71? That's 337, right? Is that it?
No.
No.
Why isn't it?
Well,
David,
also, because there are repeated numbers like 21, 15, and 30.
Yep,
But
that's exactly.
then we also gotta do plus the number that LCM of 7, 5, and 3, because then that was repeated and deleted too many times.
Yep, that's exactly right. Okay. This is called the floor function. Okay. And basically when you divide numbers and then you put a floor function on it, you don't want the decimals or the fractions. It's just the whole number. So 100 divided by 9 would have been 11 and 1/9, but you just want 11. Yeah, so that's basically it. So what is that useful for? Well, it's useful for this because in example 1, we're trying to find the numbers less than 501 that are divisible by either 3, 5, or 7. So it doesn't have to be like all of them. As long as you're divisible by one of them, it's good already. So those are divisible by 3. You just use the floor function and then 500 divided by 3. That's 166. So there are 166 numbers that are divisible by 3 that are less than 500. Yeah, so you do the same thing for 5 and then 7, and then you get 171. I was asking the class why we couldn't just add everything and get 337. You couldn't do that because some numbers are repeated, right? Like over here, there's 15 here and 15 here. So if you just count and add everything, 15 would have been counted twice, right? Because it's divisible by 3 and it's also divisible by 5. So what do we have to do? Well, we'll just subtract those that are divisible by 15, right? The LCM of 3 and 5. So it's quite easy. Just use the formula again. Our function of 500 divided by 15 is 33. So 33 numbers that are divisible by 15. Okay, but multiples of 15 aren't the only ones that are repeated. What else are repeated? Anyone have any ideas? Is it only multiples of 15 that are repeated?
It's also 35.
Yeah, 35 and 21, right? Because 21, you count it here because it's divisible by 3 and it's divisible by 7. So the number of numbers that are divisible by 21, 23, divisible by 35, that's 14. Okay, you know what? Let's try to list it down. Let's see what we've got. Multiples of 3, 6, 9, 12, 15, 18, Okay, all right, so basically this is what we're gonna do. We're gonna add everything, right? And then we were about to subtract like the numbers that are multiples of 15, right? Because they're counted twice, like here. 15 is literally counted twice. 30 is also counted twice because it's a multiple of 15. So if you subtract it once, then we're good. And then what else do we subtract? We subtract the ones that are multiples of 21, right? Because 21 is over here and it's over here. So it's counted twice already. So we subtract it. Same thing goes for 35, right? So what do we have so far? We've got 166 plus 71. And then we subtract away those that are divisible by 15, those that are divisible by 21, and those that are divisible by 35. Because they're counted twice already. This is not the right answer. We should also find the numbers that are divisible by 105, right? So 500 divided by 105, take the 4 function, that's 4. Okay, I'll show you why we still have to add in 4. Right, so we listed all the multiples over here. Okay, there should have been 105 over here, 105 over here, and 105 over here, because it's the LCM of all 3 of the numbers, right? So this is what happened, just a recap. We counted it once when we added in the multiples of 3, counted it twice when we added in the multiples of 5, and then counted it like one more time when we added the multiples of 7. So at this point, right, over here, we've counted it 3 times already. Okay, but that's not it. It's a multiple of 15, so we subtracted away one of them, so we counted it like twice only. And then it's a multiple of 21, which we subtracted as well, right? So we subtracted away, now we've only counted it 1 time. And then it's also a multiple of 35. So that means we actually take it away, right? So at this point over here, we don't actually count it at all. Like we don't even count it once. But 105 is like one of the valid numbers, right? So we have to add it back in. Yep. So we just add in multiples of 105. The same thing would go for 210, 315, and 420. Yep. So that's why we add a plus 4. Because we counted 105. We want to count 105 like once. Does that make sense? So basically the steps are add all of this, subtract all of this, and then add this back in. Okay, have any of you like dealt with Venn diagrams before? No? Have you done the 3 circle ones? Yeah, it's actually the same thing, right? Yeah, where you add everything, subtract the ones that are common to 2 of them, and then add back in the ones that are common to all 3.
If you use a Venn diagram, it will take way too long if it's in a test.
Oh yeah, of course. But the strategy is the same. Add, subtract, and add again. So this is the multiple of 3 and 5. I mean the LCM of 3 and 5, the LCM of 3 and 7, and the LCM of 5 and 7. This is the LCM of all of them.
Where is the answer?
Oh yeah. Shoot, I forgot to add it. It's 271.
My answer is in the chat.
Yeah, your answer is right.
The answer is 271 numbers. If you find this video helpful, please smash that like button and don't forget to subscribe to our channel for more math content like this one. Now that's Tiger logic, no dividing. Your turn, same trick, new number. How many numbers less than 20, 25 is divisible by 6, 14, and 21?
Let's try out practice 1. Okay, so let's do the same thing. Find the numbers that are divisible by 6. Right? Floor function of 2025 divided by 6 is 337. The numbers that are divisible by 14 are 2025 divided by 14. Take the floor function, that's 144. And divisible by 21, that's 96. So we find the LCM of 6 and 14. What is that? 42. So the number of numbers that are divisible by 42 are 2025 divided by 42, that's 48. The numbers of the LCM of 6 and 21, that's still 42. And if you solve for the LCM of 6 and 21, 14 and 21, that's still 42. So the LCM for all 3 of them are actually 42. Will it still work if I just carry on with a formula? Yeah, it would. Yeah, but anyway, I think this is a better way to explain it. How many times is 42 counted if I add everything over here? 42 is counted once over here because it's a multiple of 6. It's counted over here because it's a multiple of 14. And it's counted over here because it's a multiple of 21. So at this point, it's counted 3 times, right? And we only want to count it once. So we subtract it twice. That's why we do this. 337 plus 144 plus 96. And if we add all of these, 42 would have been counted 3 times already. So we subtract it, but 2 times. Yep, so minus 2 times 48 is 481. Does that make sense? You just kind of have to think like, oh, it's counted once over here, counted once over here, counted once over here. So it's counted 2 more times than it's supposed to be. So it subtracted 2 times. Yeah, so that's why it's minus 2.
The answer is 481 numbers. Last one, and it's sneakier. Watch which digits actually matter here. Find the smallest possible 6-digit number 15ABC6 such that it is divisible by 36.
Okay, so this one. Okay, what does it mean for a number to be divisible by 36? Can anyone tell me the conditions? I mean, there's no divisibility rule for 36, right?
The last 2 digits should be divisible by 4, and the sum of the digits should be divisible by 9.
Yeah, that's basically it. For it to be divisible by 36, okay, so 36 is equal to 4 times 9, right? For it to be divisible by 36, it has to be divisible by 4 and by 9. And these two numbers have to be relatively prime, okay? What does that mean? They cannot have like common factors. I mean, I could just say like 36 is equal to 6 times 6, right? And then, I can just say like, it has to be divisible by 6 and 6, which is just like, it has to be divisible by 6. But that's kind of stupid because like, yeah, if it's divisible by 6, it doesn't mean it's divisible by 9, right? Yeah, so we can't do this. These two numbers have to have no common factors. A few other examples would be like divisible by 24. 24 is equal to 4 times 6, but we can't really do that because 4 and 6 have common factors. So this is a no-go. What you should do is do 3 times 8. 3 times 8 have no common factors. Yeah, because I mean, like, if you just check divisibility of 4, right? It doesn't mean it's gonna be divisible by 8, and multiples of 24 are divisible by 8. Yeah, so you have to do it this way, 3 times 8, not just 4 times 6, not 2 times 12. All right, so divisible by 4 and 9. I mean, divisibility by 4, as Atri said, check the last 2 digits. If they're divisible by 4, then the whole number is divisible by 4. So the last 2 digits are C6. So C6 is a multiple of 4. So the options of C are just 1, 3, 5, 7, 9. Okay, just another tip, right? Please don't forget 0, because so many students forget 0 when we're looking for like possible values, right? Yeah, but I mean, in this case, yeah, it's not possible because 6 is not a multiple of 4. The only time 0 is not allowed is if you have like a A124 or something like this. 0 cannot be the first digit. Otherwise, it's not going to be a 4-digit number. Don't forget your zeros. Okay, so these are the possible values of C. What do we do next? We want the smallest possible 6-digit number. So why don't we just let A equal 0? Because that's as small as we could get it, right? 5 ABC 6. So we let A equal 0. Okay, so what do we have so far? It has to be divisible by 9. So Atri mentioned that if you add all the digits, it has to be divisible by 9. So adding all the digits, right? 1 plus 5 plus A. Well, A, we assumed it to be 0 for now. So that's 0 plus B. We don't know what B is yet. So we'll just leave it. And then 6. We don't know what B and C are yet. So we just do 1, 5, 0, and 6. So that's 12. So B plus C plus 12 has to be a multiple of 9, right? Because this is the sum of our digits. We set A to be 0, and then 1 plus 5 plus 0 plus 6 plus B plus C has to be a multiple of 9. So what are the options that I have? There's only one way to do it. What's the possible like sum of B and C? Anyone have any ideas? Can B plus C be 5? Is this going to be divisible by 9 if this is 5? No, right? That's only 17. That's not even a multiple of 9. So B plus C has to be 6 because 18 is a multiple of 9. Yep, yeah, okay, so B plus C has to be 6, sorry. Yeah, and then what could B and C be? Could anyone like give an example of a possible pair B and C? I want the smallest one, by the way. So if I want the smallest one, why don't I let B be 0? Is that even possible? So B plus C has to be 6, right? B and C. Is it possible for B to be 0 and C to be 6? Well, C cannot be 6 because in our options for C, we only have 1, 3, 5, 7, and 9. So this is not possible. Okay, if you want the next smallest, B could be 1 and C could be 5. But that's possible because C equals 5 is a possibility. Yeah, so that's it. If you want the smallest one, that's basically 1, 5, 1, 5. A is going to be 0, B is 1, C is 5. 6. So this is the smallest. 150, 156. If you add all the digits, that's 18, which is divisible by 9, so it's divisible by 9. Also, the last two digits, 56, are divisible by 4. So that means divisible by 9, divisible by 4, yes, divisible by 36. Yeah, that's it. Okay.
The answer is 150156. Smart move, champs! Tell us in the comments which number you cracked fastest. Spotting divisibility is one tool. The full example